Alright, in this video we'll be looking at a couple of examples of harder area problems. The first one will be a square with a circle missing. So we need to do each of those pieces separately and then put them together afterwards. So we look only at the entire square first. The area of a square is quite easy. It'll be 6 times 6, which is 36. But now we need to think about the circle in the middle there. And to get the area of a circle, you need its radius, and so you need the length from the middle to the edge. But we can see that that's going to be half of the length of the square, which is going to be 3. And so knowing that radius, you can work out the area of the circle to be pi multiplied by 3 squared. Calculator that, we get 28.27 or so. And so back to the original question, we had to get the circle in red and we had to remove it from the square, giving us a final area of 36 minus 28.27 to remove the circle, which gives us about 7.73. Alright, the next one will be a shape that looks a bit like this with these measurements as shown. Now this shape is made of 2 simpler shapes. On top we have a triangle, an isosceles triangle actually. On the bottom we have a semicircle, and once again we do each of those ones separately. So we start with the triangle on top, this one in blue here. Alright, the area of any triangle is always half times base times height. Now we can see the base is 12, but the height is not 10, right? The height is marked in here. It's got to be perpendicular to the base, and so we don't know what that height is right now. The best we can say is the area equals, well, half times 12 times h, whatever the h is. All right, so now we've got to work out, we've got to pause here and work out what is that h equal to. And to work that out, we need to look only at the right angle triangle where the 12 has been split into 6 and 6, and we're looking only at 1/2 of that. Why would we do that? Because now we can use Pythagoras to work out what the h equals. Right? So what do we do with Pythagoras? Well, we need to first locate the hypotenuse, which is opposite the right angle, so it's going to be the 10 in this case. And so because the 10 gives us the largest square for Pythagoras, then h squared must be then the difference between 10 squared and 6 squared, which is 64. And so h squared will be 64, h is the root of that, which is going to be 8. Okay. And so knowing that, we can move back to the left there, and the area is half times 12 times 8, which is equal to 48. And that's the area of just the triangle. So now we move across to the semicircle, the shape on the bottom there. The area of a circle is pi times radius square, and we've kept the 6's there because they are the radius of the circle. So the radius of the area of the entire circle will be pi times 6 squared. We don't have the whole circle, we only have half the circle, so we multiply that by 1/2. We do that in our calculator, and we get 56.55 or so. And so now once we've got the bottom half as well, we can add those together to get the final area. And from there, we get 104.55. So the basic idea for these harder shapes is you want to split it into simpler shapes that you can work with. Sometimes you can't get there straight away. Sometimes you need to use Pythagoras or some other tricks to work out what the area of each individual piece is. But once you have those pieces, you can put them together either by adding or by subtracting and work out the final answer from there. So that's all for today. Thanks for watching.